Good morning, students. I am Srimati V.V. Ramalakshmi, Senior Lecturer in Civil Engineering from Government Polytechnic, Vikarabad. The name of the subject which we are going to discuss is hydraulics. The code of the subject is 18C 404C. And the topic for today's class will be the first unit, that is the properties of fluids. And the subtopic is going to be introduction and the various properties of fluids. So students, the duration of the class is going to be 50 minutes and I'm going to teach you with the help of some sketches and photographs. So are you all ready? Are you all ready, students? So get ready to listen to the new subject of hydraulics. So hydraulics means, it's a Greek letter. Hydra means water and leaks means study. So we are going to study about water, the study in detail about water. So as you all are aware that water is available everywhere on the earth, wherever you see, but we have to streamline the water and try to utilize the water in a proper way. And as a civil engineer, from our civil engineering point of view, we are supposed to uh, take care of the water and use it effectively. So on the completion of this period, the objective of the class is going to be, you will be able to explain the scope and importance of the fluid mechanics or hydraulics in civil engineering, and then the different properties of the fluids. So next we are going to see the introduction into the fluid mechanics. So students, as we are all aware, matter exists in how many forms? It is in two states. So it is the solid state and the liquid state or the fluid state. Then in the solid state, as you all know, the solids are compact, rigid, and resist shear stress to its capacity. So that means in the solids, the molecules are closely packed. So this concept already you know in your school days in your physics. Since your school days in your subject of physics, you already know the matter exists in the two states. Then coming to the fluid state is going to be a state in which the molecules are going to be more farther from each other, and then a fluid is something which flows. Liquid is different from a fluid. Both have very slight difference. So what you must understand is fluid means something which can flow. So a state of the fluid is the state in which it deforms continuously under shear stress. So that is what is the two states in which the matter exists. So now coming to the fluid mechanics. So fluids may exist in liquid form or gaseous form. So both liquid and gas form of the matter, it can be grouped into the fluids. So now liquids means what? So basically liquids are something which possess definite volume and they are incompressible. That means we cannot compress them. The volume cannot be reduced of the liquid. Suppose you take a liquid into a cube and try to give pressure or forces from all the sides. Can you reduce the volume of the liquid? Is it possible? No. So you must have tried, or if you try also you cannot do it. Why? Because the liquids are simply incompressible. Then coming to the gases. So gases, you have oxygen everywhere. Unless you have oxygen, you cannot breathe. So, but you cannot see it. So gases, they don't have definite volume and they are compressible. Suppose you take some gas into a container and then you can try to apply pressure to it. So they can be compressed under certain conditions. So this is the basic difference between the liquids and gases. So now coming to the fluid mechanics. So this is this branch of science which deals with the behavior of fluids at rest or in motion. So students, here let us see about the scope of the fluid mechanics. So when we come to the scope of this fluid mechanics, so it can be applied in the fields of hydraulics, hydraulic machinery like pumps and turbines, then water power engineering, aeronautics, chemical engineering, etc. So these are all the areas in which you have the application of the fluid mechanics or hydraulics. So hydraulics, coming to our subject, hydraulics. So this is the branch of science which deals with the behavior of fluids at rest or in motion. Then coming to hydrostatics. So what is this hydrostatics? Static means something which cannot move. So hydrostatics means it is a branch of science which deals with the behavior of fluids at rest. So when the fluids are not going to move, they are going to be standstill. Then you have pressures. So suppose you have the fluid inside the dam, which is getting barricaded by a dam. So it is still. So then the liquids is at rest. So that branch is called hydrostatics. Then when the fluid is moving or you have the water running into the river, inside a river, so that is hydrodynamics. So coming to kinematics. So that is the branch of science in which the behavior of the water in motion without subjecting it to any external forces. So that is hydrokinematics. Then coming to hydrodynamics. So it is the branch of science which deals with the behavior of water in motion under external forces. So in kinematics, it is not subjected to any external forces. In hydrodynamics, it is subjected to some external forces. So the effect or influence of external forces will be there in dynamics. So that is the difference. So now coming to the different properties of the fluids. So basically fluids have got certain properties, and unless we study the properties of these fluids, we cannot understand the subject of hydraulics or fluid mechanics. So usually the civil engineers handle the subject as hydraulics, and almost the same subject is handled by the mechanical engineers or the automobile or other engineers as fluid mechanics, because the fluid which we deal with is going to be only water. That is why hydraulics, hydra means water, as I told you in the beginning itself. So now for them it can be any oil because they will be dealing with the machinery. So they should know the movement of the oil or the viscosity of the oil or the properties of the oil which is moving into the machinery. So that is why, or the aerodynamics and all, these people, they take the fluid dynamics. So that is why they study the fluid mechanics. So the subject is a little bit different. So from our point of view, we are going to restrict ourselves to hydraulics. So let us see the various properties of the liquids. So the first property is the density, or it is also called the mass density. Next, the specific volume. Then the third one is the specific weight or weight density. Then coming to the fourth one, it is the specific gravity or relative density. Some of these terms you must have already been familiar with in your physics or chemistry also. Relative density, mass density, all these things are terminology which you have heard in your physics or chemistry subjects. Now coming to the compressibility, then the property of getting compressed. Then coming to the next one is surface tension, and then the capillarity, then viscosity, and the last one is the vapor pressure. So these are all the various, this is the list of the various properties which a liquid is going to possess. So let us see one by one. Okay, so the first one is the mass density. It is represented by a Greek letter rho. So as you see, a rho is a symbol very similar to small p. So you must identify, always you should know the terminology, what symbol you are using for what. So now mass density means it is the mass of the fluid per unit volume. So the unit volume, it can be 1 centimeter, 1 meter, or any other 1 feet or any other unit. So it is the mass of the fluid, that means the content. Mass means the physical content of the fluid. So per unit volume at standard temperature and pressure. So these conditions have to be maintained. So it is expressed in mass units are kilonewtons. It is kilonewtons per meter cube. So this is the mass density. So then the specific volume. So coming to the specific volume, sorry students, here the mass means mass will be in kgs. So the unit by mistake it has come kilonewtons. So please correct it. It is kgs per meter cube. Meter cube is the unit volume. So meter into meter into meter. LBD. So L in meters, B in meters or D in meters. So volume has got 3 dimensions. So that is why meter into meter into meter is going to create meter cube, and this is kgs per meter cube. Then the next property is specific volume. So it is represented by 1 by rho. So as it is indicating, 1 by rho means it is the reciprocal of the mass density. So volume of fluid per unit mass. That means it is just the opposite. So just identify mass density is mass of the fluid per unit volume, and specific volume is volume of the fluid per unit mass. That means it is, so now let us try to derive the units, students. So what is the unit for volume? It is meter cube, and unit for mass, it is kgs. So the units for the specific volume will be meter cube per kg. That means the unit also is the reverse of the mass density. So these both are opposite to each other. So 1 by, that is why it is expressed as 1 by rho. So now students, the next property is the specific weight, and this is going to play an important role. This, remember, this small w is going to be used in many places in our calculations in the subject of hydraulics. So what is this small w stand for? It is the specific weight. So now weight means, all of you know what is weight. It is the force by which you are being attracted towards the center of the earth. So all of you have your own weight. Do you know your weight? All of you must be knowing. So around 50 kgs or 60 kgs or 70 kgs. So that is the weight. So weight is always expressed in newtons because it's a force. So weight of the fluid per unit volume. The unit volume can be centimeter cube or meter cube or feet cube if it is the FPS systems. So now students, here it is expressed, the specific weight is expressed in kilonewtons per meter cube. Then coming to the specific weight, it is the mass. So do you all remember the second law of the Newton? F is equal to ma. So weight is a force, so that is F is equal to m into A. So mass into acceleration due to gravity. Here mass can also be expressed as the mass density. So mass density is rho into g. So W is equal to rho g. So this is one expression by which you can find out the specific weight. So here students, next item is the specific gravity. So specific gravity is expressed as small s. Now it is the ratio of the specific weight or density of that liquid by specific weight or density of pure water at 4 degrees centigrade. That means this is the temperature at which the water, the weight of the water has to be taken. So that is the ideal temperature. That means, so whenever you want the specific gravity of a particular material, so the specific gravity or density of that liquid by, you have to compare it with a standard liquid, and here the standard liquid for us available is water. So you try to take the ratio with water. So here it is. So now then the standard, let us see about the standard values for liquids. So the mass density rho is equal to 1000 kgs per meter cube, and then the specific weight of water is going to be 9810 newtons per meter cube. So this value you have to remember, student. Sorry. So this is very useful value which we will have to substitute in many of the equations in our fluid mechanics or hydraulics. So this value for water is a standard value. So that is why you must remember it. So next was mass density also. This is 1000 kgs per meter cube. Then the specific gravity of water S is equal to 1, because specific weight of the liquid, and when you compare it with the same liquid, so it is 1. Specific gravity of the water is 1 gram per cc you can take. Then the specific gravity of mercury, because mercury is a heavy liquid. Usually mercury you find it in the thermometer, and you have the mercury lamps also. So thermometer, inside the thermometer, for finding out our temperature, we will usually use the thermometer. Also everywhere you can find the thermometer for getting to know the outside room temperature and other things. So the room temperature usually it will be 27 degrees centigrade. So the specific gravity of mercury is a value which varies from 13.5 to 13.6. Usually for our problems we will be taking the value of 13.6. So now let us go to the next property. So the next property of the fluid is compressibility. It is very important. So air is compressible. So air, if you try to gather the air and then put it inside a box and then close it. So you can try to apply pressure and see the balloon. You see the balloon when you blow air inside to it and then tie a rubber band or a thread, you can just fly it up. So you have tried to compress the air and put it inside. If you just blow with your mouth, the air you have tried to put it inside, then we are going to see how the air is going to react. Then it will just fly because it is lightweight. So here when coming to the property of compressibility, air is compressible. And coming to the water, so water is incompressible. You just cannot compress water. You just cannot apply pressure or try to reduce the volume of water. So let us take it for granted that water is incompressible. Now the property by which a liquid changes its volume when compressive force is applied. So that is called the compressibility. Then compressibility is inversely proportional to the bulk modulus. Bulk modulus is related to the volumetric change. So that is the compressibility small c is inversely proportional to 1 by k. So directly proportional, you can directly write the symbol. When it is inversely proportional, you have to write it 1 by k. So now let us see what is this bulk modulus. So the bulk modulus K is equal to the rate of increase in pressure per unit change in the volume per unit volume. So increase in the pressure, which is going to be the change in the volume per unit volume. So dV, small dV is the change in the volume, and volume is, unit volume is small v. Then so K is equal to dP by dV by V. So dV by V is the volumetric strain, then this is the change in the pressure. So that is how when you apply pressure, you will have change in the volume, small change in the volume. That change in the volume per unit original volume is the bulk modulus. So students, this is a relative term. So now pressure by volume. So this is kilonewtons per meter square. So change in the volume is meter cube, and then again this is also meter cube. So here meter cube by meter cube, the unit gets cancelled off. So you remain with the unit of the pressure, which is pressure means it will be force per unit area. So here comes your units, kilonewtons per meter square. So the denominator unit is not going to reflect in your bulk modulus. So students, then let us now explore into the fluid mechanics properties. So the properties of the fluids are, in certain cases, just keep thinking. So do you know why the diamonds are smaller than any other materials? We'll be seeing, and most of us will be seeing diamonds in very, very small, as small particles which are going to be shining. Mostly many people will be wearing rings and earrings or necklaces, you'll be seeing. So in our day-to-day life, so why are they so small, or why are they so shining? Let us see why this is happening, why it is glittering. Then another question which you will get in your mind is, why the mercury, that is Hg, the symbol for mercury is Hg, why it does not wet the surface with which it is in contact, like glass. So if you put a mercury into a glass tube, if you remove it, it is not going to touch the surface of the glass. It will same is not the case with the water, whereas the water wets the surface. Suppose you take a glass, you take a glass tube and then put water inside and then pour it again back, so you'll see some droplets which are going to stick to the wall of the glass. So why this is happening for water and why it is not happening for mercury? So what property is associated with this concept or this phenomenon? So let us see or think about all these things. You are going to get the solution for all these questions in this chapter itself, and I am going to give you the answers and we are going to discuss about it. So now let us see. It is, so the answer will be, it is due to the properties of cohesion. The term is new to you, so underline this term, cohesion and adhesion between the molecules. So here students, what are these new terms cohesion and adhesion? So adhesion means you must have heard this term adhesive. So you in our daily life, day-to-day life, we'll be seeing a small tube called fevicol, which we'll be using it for sticking the things or gluing the things. Gum, fevicol, all these quick fix, all these are lubricants which are going to be used for sticking. When we do some paper art or while we glue something, you'll use gum. Gum is little bit not that effective or it is not that strong. When it comes to quick fix or fevicol, so it is having good adhesive properties, that means sticking properties. So then this term is associated with the adhesion. So coming to the liquids, the same terminology is applicable for the liquids between the molecules of the liquids. So let us see this two terms. So in the properties of liquids, let us see the adhesion. It is the property of the liquid by which the molecules of one liquid attracts molecules of another liquid or solid in contact with it. So adhesing means sticking. So when you put water, the water molecule is different and the side or the solid molecule is different. Side of the wall of the vessel, it is different. So these two get attracted towards each other. So and then the force of attraction between the liquids, that means the molecules of the liquids itself, any liquid contains number of molecules. So there is force of attraction between liquid to liquid molecule and liquid to solid molecule. So this force of attraction or this property of the liquid is called adhesion. Then coming to cohesion, it is the property of the liquids by which molecules of the same liquid get attracted towards each other. So the same liquid means, suppose it is water molecules, two water molecules get attracted towards each other. And then this property is called cohesion. If it is different liquids, it is adhesion. But if it is the same liquid, it is cohesion. And then next, so because of these two properties only, you have many things associated, many phenomena associated with the properties. So let us again question ourselves. There are a few questions with which we'll have to think, about which we'll have to think. So why a drop of water assumes the shape of a sphere? See, whenever you see the rain droplets coming down in the rainy season, now we are having rainy season. So you see the rain droplets, they are almost one by one drop. So how are they forming? So how are they getting that shape? So because water is having some property, otherwise it cannot have that shape like a bundi, like rounds like a bundi. What you see, the like the bundi of a laddu, is it not? So similarly, how it is getting formed in nature, God has created all these things. So everything is getting formed naturally. So what is the property behind it? Let us see. So again, another question, students. So why small insects are able to skate across the surface of the pond? So they are just going to swim, not swim because they are lightweight. They are going to suppose you see a dry leaf which is going to just be on the surface of the water without sinking, or light some small objects also are able to just be there on the top of the liquids. So how all these things are happening? So why objects of greater density than water can be made to float? So because you see the ships are submarines, all are inside the water or over the water. So these are all It is all related to the hydrodynamics and other things. So it is all due to the property of the surface tension of the liquids. So this another property, new property which we are going to learn about. So all these, because of all these questions, water droplets forming, small insects skating on the surface, and then the objects of greater density than water are made to float. So it is all happening because of the surface tension of the liquids. So now let us see, look here at this picture, the formation of small droplets on as surface tension. So water droplets are formed because of surface tension. So look here, on a surface you have all these small and big water droplets. So this shape, this look is very magnificent. So this happens in our day-to-day life. We'll see this is a situation when water is in the form of droplets. So because of surface tension only, water can take this phenomena. Next, so let us see, students, what is this surface tension? We have seen different types of tensions. So now in your engineering mechanics, you have seen the tensile force. So which is going to elongate, make the body elongate. Because this tension is created on the surface, it is called surface tension. So it is defined as the tensile force acting on the surface of the liquid per unit length. Okay, students. So the tensile force acting on the surface of the liquid per unit length, let it be 1 meter, 1 centimeter or 1 feet. So this is going to be the surface tension and it is represented by the symbol sigma. Now it occurs. Why does it occur? The reason is it occurs due to the cohesion between the liquid particles at the free surface. Now I'm going to give you a view of the molecules, what is actually happening internally. You'll be just able to visualize by looking at this picture. So the surface of the liquids, so the surface tension of liquids decreases. Remember here, it decreases with the increase in temperature. So what happens, students? So usually suppose you take water. So when you boil the water, what is happening there? As you are increasing the temperature, the molecules are going to scatter. So that is what happens if you have any elasticity or the surface, the force on the surface of the liquid, it is going to be lessened with the increase in temperature. When the temperature is increased, because of the heat, the molecules are separated and scattered. So that is what happens. So the surface tension of the liquids decreases with the increase in temperature. So this parameter you must remember, this concept, right? So it is inversely proportional. Now let us see the phenomena of the surface tension. So look here, this is a area, this is a container, and then this is the top liquid surface. So this is the surface. So consider a molecule A which is inside or under the top. So any molecule inside the water. So it has forces on all the directions. See the 8 directions you have the forces. So this molecule can attract any molecule in and around this area. So then coming over to this surface. So at the top side you don't have anything. There is atmospheric pressure or it is open. The top liquid surface is open to the atmosphere. So then what is happening? You can, as you are able to see, you have forces of attraction only to the side and the bottom, not to the top. So here this is one side and this is the other side. So this molecule is being pulled by forces on either side, that is it is under tension. Because this molecule is existing on the top liquid surface, it is called, this force is called surface tension. So is it clear, students? So this way you consider one molecule inside and one molecule on the surface. So this way both these molecules have a different forces. So it is clear from this picture and you can explain the concept with the help of drawing such a sketch. Now coming over to the surface tension. So the magnitude of the force per unit area of the free surface will have the same value as the surface force per unit area. So surface tension is expressed in Newton per meter. So force by area, the length, Newton per meter. Now let us see the application of the surface tension on a liquid droplet, how it is going to be formed. So let sigma be the surface tension of the liquid per unit length in Newton per meter. Then small p is equal to pressure difference between inside and outside of the droplet. So Pi, look here, Pi is the pressure inside, which is going to be more than the external pressure Po. So this is the bubble, and if you take the semicircle half of the bubble, so the at the surface, if you take half surface also, you have tension towards the bottom. So this uh, pressure is going to be, the internal pressure is going to act downwards and it is going to keep the bubble in the spherical form. So this pressure difference, because there is more pressure inside and less pressure outside, so the film like is going to be formed and then it is going to be sustained. So students, you must have played with the soap bubbles. Take some soap water and then just blow it with a small straw. You must have done this exercise in your childhood. Now also you can do, and then you take the straw and then put it on the surface of the small, take a small vessel and make a little bit of surf or soap water, mix it in water, and you're going to have number of bubbles. You can just play with it. So here all these bubbles are formed because of the property of the surface tension only. So it is clear and evident seeing the soap bubble. So look here, this is the phenomena behind it or the concept behind it. So this is the tension. So now under equilibrium conditions, the tensile force due to the surface tension acting around the circumference of the cut portion, that is sigma into pi d, because it is going to act around the circumference, you are going to take the circumferential length, that means the perimeter, which is the pi into d, and the pressure force is acting around the area. So around the area, that is the cross sectional area, pi d square by 4 into small p. So now this inside force has to balance the cut portion. So now the sigma into pi d is equal to small p into pi d square by 4. So p is equal to pi gets cancelled and 1d gets cancelled. So you land with p is equal to, that means the pressure is going to be 4 sigma by d. So this is the equation for the pressure inside a bubble, soap bubble. Then this is the surface tension on a liquid droplet, and now the surface tension in a hollow bubble or a soap bubble will have two surfaces in contact with the air. So the two surfaces which are in contact with the air, that means if it is a hollow bubble, the internal circle and the external circle. So two circumferences are there. So it is like a ring. So because you have a thin film for a soap bubble, you have a thin film. So twice sigma into pi d is equal to again the pressure force from the outside, which is going to act over the cross sectional area. So now you have the surface tension. The pressure is 8 sigma by d. If you try to work out this equation by equating, this pi gets cancelled and the d1 diameter gets cancelled, and if you try to condense the equation, you're getting P is equal to 8 sigma by d. So for droplet, it is 4 times the surface tension by d, and for hollow bubble, because it is hollow means internal one diameter is there, external one diameter is there. So we can take it that way. So because it is double the area, two areas are getting exposed, we can take it as 4 to the 8 times. So that way you can remember. So bubble 8 times sigma by D. So now in the summary, in today's class, we have discussed about the scope of the fluid mechanics. We have seen the introduction part, and then the properties of the fluids. I have listed you the 9 properties. Then the mass density, specific weight, specific gravity, compressibility. Then coming over to the next different properties of the fluid are like cohesion, adhesion because of them, surface tension of the water droplet and the soap bubble. So students, a part of the discussion we have finished on the fluid properties. So now let us see a few questions in the quiz. So the specific volume is the reciprocal of mass density, specific weight, compressibility, and specific gravity. So what is the correct answer? It is, answer is A, that is mass density. Then the specific gravity of water at standard temperature. How much it is? 0, 1, 2, 3. So what is the answer, students? So specific gravity or you have it is comparison between the specific gravity of specific weight of the liquid with the standard of water. So when you are comparing water with water, you will have 1. So like that, the answer is B. Now the third question, which of the following is incompressible? Is it air or water? So water, we have discussed in the beginning only about the compressibility property. Air can be compressed and water cannot be compressed. So water is incompressible. The answer is B. Now, what is cohesion? Cohesion is due to the attraction between molecules of two different liquids, liquid and solid, same liquid, none of the above. So what is the answer, students? Yes, it is same liquid. Co means same. Colleagues, collinear, co, same. So that is why select the answer as C. Now coming to the next question, adhesion is the force of attraction between two different liquids or one liquid and solid, same liquids, both A and B, none of the above. So the answer is A, two different liquids or one liquid and solid. So the answer is A. Then surface tension is the phenomena due to cohesion between liquid particles, viscous forces, then adhesion between liquid and solid particles, then none of the above. So what is the answer, students? It is cohesion between liquid particles. So the attraction, force of attraction between liquid particles at the surface. I have shown you the picture also. Remember that figure. So remembering that figure, you can answer. So at the surface, there is no balancing force on the top side. So then the pressure difference inside and outside of a soap bubble is 8 sigma by D, 2 sigma by D, 4 sigma by D and 6 sigma by D. So the answer is 8 sigma by D, 8 times, because soap bubble means internal and external. I told you circumference, two circumferences are involved. So the pressure within a soap bubble is same as that surrounding atmosphere, greater than the external pressure, then less than the external pressure, then equal to the vapor pressure. So the answer is greater than the external pressure. Remember that bubble figure, then you will be able to correctly answer. So it is greater than the external pressure. The answer is B. Then now let us see the frequently asked questions in this chapter. Define specific weight and specific volume. Then define center of specific gravity and compressibility. Then define cohesion and adhesion. Define surface tension. All these are the possible answers which are asked in the question exam. So what is meant by surface tension? Give two examples of surface tension. So with this, students, we have finished a portion of the first chapter, that is the properties of fluids, and then just answer the questions given after going home, and then write down some more examples of surface tension, and then all these are going to come as definitions. So definitely write down all the definitions of the properties of liquids. I'm going to continue further the discussion on the properties of liquids, because it's going to be very interesting. We are, as you're able to see, it is a very interesting topic, the hydraulics. So create more interest and try to uh, write down all the questions or all the answers what all are given to you, and further we will practice problems also in the next coming class. So goodbye students, and let us meet again in the next session. Continue. So continue studying this interesting subject of hydraulics. You only will get to know that it is very, very interesting. So students, review all the topics which I have given you and come again, come prepared. I'm going to ask you questions in your next session.